This is part 2 of our introduction to exponential functions in their graphs. In this one, we're going to take a look at the graph of y equals 2 to the power of x and y equals 1/2 to the power of x. So it says graph the functions y equals 2 to the x and y equals 1/2 to the x by completing the tables of values below. So I'm going to start with 2 to the x, and when you do any table of values, what you do is you take your x values and you substitute them in for the variable in your equation. So I'm just going to zoom in a little so that I can see the equation a little bit better. So I'm going to do 2 to the power of -4, 2 to the power of -3, 2 to the power of -2. But I like to start on the bottom, and I'm going to start there. So I'm going to do 2 to the power of 4. 2 to the power of 4, you can use your calculator or your power sheet, works out to be 16. 2 to the power of 3 is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0, anything to the power of 0 equals 1. Now this is where it gets a little bit tricky. 2 to the power of -1. Well, we learned that a negative exponent makes a fraction. So here, 2 to the power of -1 is actually 1 over 2 to the positive 1. So I'm going to end up with 1 over 2. Another way you can think about it is it flips it over. If I have 2 to the power of 1 is 2, then 2 to the power of -1 is going to be the fraction version of that, which is 1/2. Now 2 to the power of -2, once again, that's a negative exponent. It's going to make a fraction, so it flips it over. So instead of doing a base of 2, we do 1/2, and we do 1/2 to the power of 2. 1 to the power of 2 is 1, 2 to the power of 2 is 4. Another way you can think about it, if this is 2 to the power of 2, 2 to the power of -2 is going to be the fraction version of that number. So if I continue that pattern, if 2 to the power of 3 is 8, then 2 to the power of -3 should be the fraction version, which is 1 over 8. And if 2 to the power of 4 is 16, then 2 to the power of -4 should be 1 over 16. I'm going to take those points and try my best to plot them on the graph. Now when I do that, I'm going to start with the positive ones down here, and then I'll deal with the fractions at the end. I find that easier. If I start with the fractions, it's a little tricky. So I'm going to come over to my graph. I have the point 4 and 16. So I think I might start by marking on a really quick scale here. I'm going to mark on the 2s. So that's 2, 4, 6, 8, 10, -2, -4, -6, -8, -10, and then going up we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 20 at the top. So 4 and 16 would be 4 and 16. And then we have 3 and 8. So 3 and 8. 2 and 4. 2 and 4. 1 and 2. And then 0 and 1. And then this is where I start with the fractions. So 1, -1 and 1/2. So 1/2 is going to be halfway in between 0 and 1. So I'm going to do my best to mark on 1/2. Then the next one is 1/4, and that's going to be halfway in between my last point and the axis. And then I have 1/8, which is halfway between that, and 1/16. And the points would just keep getting closer and closer and closer to here without crossing. So I'm going to draw this in 2 separate pieces. So I'm going to do the side that to me reminds me of a parabola. Now you'll notice I drew an arrow at the top to show that it continues on. And then this side, I like to call this side the tail. I'm just going to have it level off, and I want to continue drawing it all the way to the end of the graph, and you want to make sure it doesn't cross the axis. Now this would have an asymptote at 0, so that invisible line that I can't see that my graph is getting close to but doesn't actually cross. All right, for the next one, we're going to do 1/2 to the x. 1/2 to the x, same idea. I'm going to start at the bottom. I find that easier. So 4 would be 1/2 to the power of 4. That's really hard to see. 1 to the power of 4 is 1, and 2 to the power of 4 is 16. Okay, for 3, I do 1/2 to the power of 3. 1 to the power of 3 is 1, and 2 to the power of 3 is 8. And then I do 1/2 to the 2. 1 to the power of 2 is 1. 2 to the power of 2 is 4. Then we do 1/2 to the power of 1. That's going to be 1 to the 1 is 1, 2 to the 1 is 2. And then 1/2 to the 0, anything to the power of 0 is 1. Now, the negative exponent, right, makes a fraction. It has a flipping over action. So 1/2 to the -1 is going to flip over the 1/2 to make it 2/1 or just 2. And then to the power of 1 is 2. And like we did with the other one, you'll notice that I have the fraction here, and when I flip it over, it becomes the number. So I just end up with 2. So 1/4, if I do the negative exponent, it's going to flip it over to give me 4. 2 to the -3 would be 2 to the power of 3, but flipped over, so that's 8. And then 2 to the power of -4 is going to be the same as 2 to the power of 4, except flipped over, which would be 16. So I'm going to mark those on my graph. I'm going to start this time with the whole numbers again. So I'll start at -4 and 16. So -4 and 16. And then -3 and 8. -2 and 4. -1 and 2. And then I have 0 and 1, which is the same point that I had on the other graph. And then I've got 1/2, so halfway. And then 1/4, so half of that. 1/8, 1/16. And then I want to draw one side so that it looks like a parabola, sort of. Make sure you put an arrow on the end. And then the other side, or the tail side, is going to come down and level off just above the axis. And that's my graph.